Okay, so the title of our section is 2.1, and we're looking at good definitions. And the two learning goals for this section focus on understanding the precision of good definitions, and then understanding and using some more of the basic terminology of geometry. So we actually have quite a bit of vocabulary in this section. Okay, so let's just start off talking about what makes a good definition a good definition. One of the things I want you to look out for is using clearly understood terms. So a definition is not very helpful if we don't understand the words that make up the definition. So let's try to use words that we all understand. Now, sometimes we can't use words that we all understand. So sometimes you have to look at another definition. So that's fine. The terms should be commonly understood or previously defined. So we want to know what the definition of words are within other definitions. Another thing we're going to look for is a precision. So think about what precise means in science, right? Sometimes you talk about getting precise results when you do an experiment. Well, we can talk about precise definitions. Definitions are going to avoid using words like large or sort of or some. We want to get specific about what we mean. Another thing that a good definition does is it states what the term is rather than what it isn't. So let's take a look at an example. A really bad definition of the word big would be something like this. Big is the opposite of small, right? Because it doesn't really tell us how big, what big really means. Okay, so we want to be precise. We wouldn't want to say big is sort of the opposite of small, or big is kind of large. That doesn't really give us a specific definition of the word big. Okay, so when we're thinking about definitions, we're trying to use them to identify or classify objects many times. So we want to be as specific as we possibly can so we know exactly how to construct our drawing if we're drawing some figures, or we know exactly what properties are going to apply in the figure. Okay? So let's do a few definitions here. Our first word that we're going to discuss is the word midpoint. Okay? The midpoint of a segment is a point, right? It's a midpoint, and probably you've already guessed, it's a point that's right in the middle of the segment. But we want to be really specific in our definition. So instead of saying a midpoint is in the middle of the segment, we say it's a point that divides the segment into two congruent segments. So if we look at this picture right here, we would say that M is the midpoint of segment AB if segment AM was congruent to segment MB. And so one of the things that we might include on our picture here are those little markings. So we might put two little markings here, two little tick marks there, and that indicates that the segments are in fact congruent. So we'd say M is the midpoint if those two segments are congruent. Another thing that you want to look for in a good definition is a definition that's reversible. And we'll talk more about this later in one of our other units. But we want to be able to switch around what comes after the if and what comes after the then. So here's two different ways of defining a midpoint. One way you could say if segment AM is congruent to segment MB, then M must be the midpoint of segment AM. But we can switch that around. We'll use a different segment, different letters here. If N is the midpoint of segment CD, then segment CN is congruent to segment ND. So you see how we kind of reversed what came after the if and then. And that's really a key component to telling if something is a good definition or not. All right, here's another vocabulary word. We have bisectors, and actually we have a couple different kind of bisectors that we're going to talk about. The first one is a segment bisector. And a segment bisector is a segment, ray, or line that intersects a segment at its midpoint. So you have to have something, you have to have two things here, right? You have the segment that's getting bisected, and then you have something else that's doing the bisecting, right? So let's take a look at some examples here. A segment bisector is always going to divide the segment into two congruent segments because it goes through its midpoint, right? So we've got two columns here. we've got things that are segment bisectors, and then I've got some examples of things that aren't segment bisectors. So you can look for the difference, and if I give you a diagram, how can you tell if something is a bisector or not? So let's look at this first picture right here. We've got this segment right here, and you can see in it the two little congruent marks here and here. Then we have a line that is intersecting that segment at its midpoint. So this line is a segment bisector. Okay, now let's look at this diagram right here. Again, we have our segment. It's kind of rotated a different direction, but again, we see the little marks that indicate we have congruent segments here, so I know that this point is a midpoint. And again, a line that's intersecting the segment at its midpoint, this line here is a segment bisector. Now the other two diagrams are slightly different. Again, we're starting with a segment down here, and this time we have a ray that's just coming right up. It's kind of going straight up through the segment here, and we don't see that there's not like a dot right here to show me that there's a point there, but of course there is a point, right? It doesn't have any size. I don't have to put a dot there to know that there's a point there. And then we have two measurements here. We know that this little piece is 3 units, and we know that this little piece is 3 units. So since we know that those two pieces are exactly the same length, they must be congruent. So this ray must be intersecting the segment at its midpoint. So this ray is the segment bisector. And then one last example. Here we have two segments that intersect, but in this segment I know the length from here to here is 2. I know the length from here to here is 2. Therefore I know that this point right here must be the midpoint of that segment, and since that's the midpoint, this other segment must be a segment bisector. Let's look at the non-examples. Here in the first picture, we don't have a segment bisector here because we have no markings indicating that anything is congruent. Here we know for sure that it's not a segment bisector because this has one little tick mark, this has 2. They're different. That means that they're different lengths. They can't be congruent. So this ray is not a segment bisector. And then down here again we have different lengths. So these two little pieces aren't congruent. So again, we do not have a segment bisector. Okay? All right. The next thing that we're going to talk about is angle bisectors. So let's go ahead and look at angle bisectors here. Get back to full screen. All right. An angle bisector is a ray that divides an angle into two congruent angles. So bisecting is just like cutting something in half, right? So here we have angle ABC, and then we're going to create an angle bisector. So I'm looking for a ray that's going to cut that angle in half. And you can kind of see in the other picture, it goes right through the middle of the angle. Now what you're going to look for in the picture is some kind of indication that these two little angles are congruent, right? So we put those little congruent marks in your diagram here like this, right? So I could say that ray BD is the angle bisector of angle ABC. And if that's true, then again I know that angle ABD right here is congruent to angle CBD right here. Another definition we had to talk about in this section is perpendicular, and I think you're probably already familiar with this word, but just in case, let's get a specific definition. If I'm talking about perpendicular lines, we're talking about two lines that intersect to form right angles. So here we have our two lines, EG, line EG and line HF, and we can see those little squares on here so we know for sure that they're right angles. Now this little upside down T is the symbol for perpendicular. So what we would write on our paper is line EG, that little upside down T, and then line HF. What we would say out loud is line EG is perpendicular to line HF. And of course you don't just have to have lines that are perpendicular. You could have segments that are perpendicular. You could have rays that are perpendicular. So you could have a diagram like this. They don't even have to be intersecting all the way. But if you had something like this, and again you're looking for that little square, we could say that segment is perpendicular to that ray, and that's just fine. Okay. So perpendicular, two lines that intersect to form right angles. Now, what about this? What if we combine the word perpendicular with the word bisector? Now we have what we call a perpendicular bisector. And that is, well, first of all, you can only have a perpendicular bisector of a segment. Because remember, a segment has length, so we can cut it in half. A ray doesn't have length. We can't bisect it. A line doesn't have length. It keeps on going on forever, so we can't really bisect it. But a segment has a beginning and an end, so we can cut it in half. Okay? So a segment bisector is going to be a line, a segment, or a ray that's perpendicular to a segment at its midpoint. So not only is it a bisector, but it's also going to be forming right angles. So here's just a picture of what we mean by that. We say line CD is the perpendicular bisector of segment AB. And I know it is because I see the right angle here. And of course, if that's a right angle, this would be a right angle over here as well. I see the congruent marks here to show me that segment AD is congruent to segment DB. So we know that D is the midpoint, and then line CD is intersecting at D, and we've got that right angle there, so we're good to go. Okay, we're almost done. We just have one more example that I want to take you through with using some of this language and then doing some problems with it as well. So